Hello students, today we are going to solve the first numerical of grid chamber. Question will be given as data for grid chamber is given, that is the length of grid chamber as 7.5 meter, flow through velocity as 0.3 meter per second, depth of wastewater as 0.9 meter, specific gravity of grid as 2.5, viscosity is given as 1.002 into 10 to the power minus 3 Newton second per meter square. Find the diameter of particle that will be removed with 100% efficiency. Now we need to find the diameter of particle that will be removed with 100% efficiency. So we will write all the given quantities. After that we will solve this numerical. Okay. Now what is given in the question? That is the length is given as 7.5 meter. Okay. Now flow through velocity, that is the horizontal velocity, is given as 0.3 meter per second. Now the depth of water, that is height, is given as 0.9 meter, and the specific gravity of grid is given as 2.5, and the viscosity, that is dynamic viscosity, mu, is given as 1.002 into 10 to the power minus 3 Newton second per meter square. Now efficiency is also given as 100%. Now if efficiency is 100%, now what will happen? If efficiency is 100%, then it will be the ratio of Vs upon V naught into 100. Now if efficiency is 100%, then Vs is equals to V naught. Okay. Now both the velocities, that is the settling velocity and overflow rate, will be equals. Okay. Now we need to find the overflow rate from the given data. That will be equals to L upon VH will be equals to H upon V naught. Now we put all this value, that is length value as 7.5, VH will be equals to 0.3, height will be equals to 0.9, and from this we can determine the V naught value, and V naught will comes out as equals to 0.036 meter per second. That will be the value of overflow rate, that is 0.036 meter per second. Okay. Now Vs is equals to V naught, so Vs will also equals to 0.036 meter per second. Clear? Now the formula of Vs is equals to rho gd square upon 18 mu into g minus 1 according to Stokes law. Now we have all these values. Now we need to determine only the d square value. So for the calculation of d square, we just write here as 0.036, and it will be equals to 1000 into 9.81 into d square into 2.5 minus 1 divided by 1.002 into 10 to the power minus 3 Newton second per meter square. Okay. And 18 is also there, that is 18 mu. Okay. Now after solving this equation, we can determine the value of d, which will be equals to, when we convert all this value from meter to mm, it will be equals to 0.21 mm. That will be the particle removed with 100% efficiency, having horizontal flow velocity equals to 0.3 meter per second. That will be the size of particle, which will be equals to 0.21 mm. That is all about this numerical. Thank you very much, students.